All right, here. So we've got AP free response question. Here it is. It gives you a bunch of f of x's and a g of x's and different things like that with the prime values as certain particular values, some of which will get used and others no. First thing you got to do here is they tell you that k is f of g of x, and they want a tangent line. So you recall that the tangent line formula is y minus uh, y1 equals the slope times, x minus x1, or the x coordinate. In this case, the x coordinate they give us is 3, right? And so you would need to evaluate k at 3 here for this one. And then you'd also need k prime of 3, which would end up being a 10. Okay, k prime of 3 is just a chain rule because they tell you that k is f of g. So therefore, the chain rule tells you that it's f prime of g times g prime, all evaluated at 3. And those values are given up here, okay? And I actually looks like I forgot to write the actual tangent line itself. So it's y minus k of 3. And so that would be f of g of 3. So g of 3 is actually 6, and then f of 6 would be 4. So that's going to be a 4 equals 10, and then this is just going to be x minus 3. This would be a sufficient tangent line to get all the points on the AP exam. Part B is just a simple quotient rule. So you're just doing H. They give you G and F. And so you're doing, derivative of the bottom and derivative of the top. Oops. Sorry, this should not be prime. That should just be, that one should not be prime there. So that was supposed to be a 1, and that's a 1 as well. And it's fg prime minus g prime f all over f squared, and it's all 1s. And so you're just going to go ahead and get all those values up here. So it's -6, 3, 2, and 8. -6, 3, 2, and 8. They get plugged into here. Now, this is the most difficult one here. They're asking us to take the integral of a second derivative. But it turns out that there's actually a function within here. So you're going to make a u substitution here to solve this one out. You let u equals 2x. If you differentiate both sides of this equation, you get du over 2 equals dx because you pass the 2 over through division. Then you got to change your endpoints here in terms of x into u. So if x is 1, u equals 2, because I'm using this formula here. X is 1, u is 2 times 1. When x is 3, u is 2 times 3, or 6. So therefore, now my endpoints for where I'm going to integrate are going from, instead of 1 to 3, it's from 2 to 6. And then my substitution here, 2x became a u, and dx became a du over 2, right? So I go ahead and I differentiate that. And now, I go ahead and substitute that in. And now, finally, here, just the integral of a second derivative is the first derivative. Plus c. But since this is just going to work out to be a definite integral here, I'm going to drop the c because then I'm going to evaluate this from 2 to 6, right? And so I go ahead and I do that. F prime of 6 minus f prime of 2. Now those numbers are actually given to us way up here in this chart. F prime of 6 is 5, and f prime of 2 is -2. So I go ahead and I put those guys in there. Don't forget that 1/2 came from the fact that du was over 2 there. And so that one required a little bit of a u substitution there. All right.